We love physics. I see it. Only there? Oh, that's a good shot! That's a good shot! Yes! So, a neutron walks into a bar and orders a Coke. He asks the bartender how much it costs. The bartender replies, "For you, no charge." My name's Jette, and I love physics.
My name's Eustis, and I love physics.
Hi, my name's Reid Holden, and welcome to another episode of Fun with Physics.
Welcome to Fun with Physics, episodes 17 and 18, electrical forces, fields, and capacitance.
This is the salt and pepper test.
How would you separate a mixture of salt and pepper? Here's a simple experiment you can do at home. All you'll need is a plastic spoon, salt, pepper, and an insulator such as wool.
First, you want to make sure you obviously mix the two. You don't want to be out trying to cook something and get your salt and pepper mixed together. Then, take your spoon and your insulator. You want to rub them against each other to get a charge going. Once you've rubbed it for a while and you get a good charge going, you hover the spoon slightly above your mixture. And as you can see, the pepper separates from the salt. And as you can see, both have a positive charge, but the lighter pepper comes up to the spoon and is attracted to it because of its lack of a positive charge. We know that like charges repel and that unlike charges attract. As you see between the balloons and his hair, that the unlike charges between the balloon and the hair has an attracting effect. Similarly, with the wall, if you take the balloon and press it up against the wall after charging it, the force of the charge will hold it up against gravity, defeating gravity's pull down towards the Earth. We also know that two like charges do not attract. So both of the balloons have a similar charge. So when pressed together, they repel from one another.
We gotta find a way to show that.
We know that like charges repel. One way of showing this is by rubbing the two balloons and creating a like charge, then dropping them next to each other with a string. If you notice, the balloons repel each other.
Or do they?
They're spinning, so it's very hard to show.
Great job, Jette. An example of the attraction between opposite charges is the oppositely charged water and the charged balloon. As you'll see, when charged, the water will curve towards the balloon because of the opposite charges. Pretty cool, huh?
This is the Van de Graaff generator. It was created by American physicist Robert J. Van de Graaff in 1929, and it's used to create an electrical charge.
The electrical charge that's created by the Van de Graaff generator is static electricity. Another way to create static electricity is by rubbing a piece of fur on a PVC pipe. As you can hear, the static electricity is being generated from the touching of the fur and the pipe. The Van de Graaff generator does the exact same thing, but on a larger scale.
How it works. A motor-driven pulley moves a non-conducting belt around a loop. Friction causes a separation of charges. There's a positively charged pulley and a negatively charged belt. The larger surface area of the belt helps the negative charge spread across it. A grounded wire with a small comb is nearly touching the lower pulley at the base of the structure. Due to the pulley's net positive charge, negative charges are attracted from the ground and leap across the comb onto the belt. The belt then carries the negative charge up the device where it is deposited into the comb attached to the sphere. These charges distribute themselves over the outer surface of the dome. The spherical shape is best for creating an even distribution of the charge, yielding a larger charge overall.
Now, as you can see, it's pretty loud, but it's discharging static electricity. You can physically see the static electricity jumping from the sphere over to my hand.
This is an experiment showing how a Van de Graaff generator can be used. This experiment shows how the Van de Graaff generator can help light a fluorescent light bulb. The part of the bulb that is closest to the generator will acquire a negative charge. When the generator discharges, or when it shoots sparks, the bulb will flash because the negative charge will rush through its full length. As you can see, the sparks are lighting up the fluorescent light bulb.
Now we're going to do the classic Van de Graaff generator experiment. What you do is somebody with long hair, or in this case where we don't have anybody with long hair, a wig, has the charge from the Van de Graaff generator sent through it. All the hairs are separately charged with the same exact charge, so they'll want to repel each other and hair will rise. Generator on. Now as you can see, the hair is starting to rise all around the sides, trying to get itself up. And it even will attract itself to my hand, because it has a different charge in my hand as it's trying to attract to it. Today we're going to teach you how to make a capacitor.
Capacitors act as a storehouse for a charge. Many times capacitors are used to tune frequencies, to eliminate sparking in automobiles, and to store energy in electronic flash units.
Okay, our materials for making this capacitor are 2 glass jars, one that fits inside the other, tin foil cut to be wrapped around the jars, wires to be attached to the tin foil, and then to create our charge, which is static electricity, you use your pipe and fur method, as we did to show similarities between the Van de Graaff generator. Now, to make our thing, we have to wrap our tin foil tightly around the outside of our glass jars. You want to make sure that when you're wrapping the outside of the glass jars, that it is as flat as possible, because any ripples or anything will stop the charge from cleanly traveling through it. Just a small piece of tape. Okay, so now we're going to get our piece of tape, make sure that tin foil stays there nice and tight. The reason this capacitor works is because the 2 charged plates, which are the 2 strips of tin foil, can, with the insulator of the glass in between them, can easily transfer the charge between one another. Capacitors work in this function. There's other types of capacitors, like there's the plate capacitor, parallel plate capacitor, that works in the same way, that uses air in between it. Parallel plate capacitors are typically used in computer keypads, which when you push down, the charge is released from one to the other, sending a signal into the computer, and thus sending the message that you want the letter A to be typed in. So our next step is to take our wires with the fanned out wire strip and place it on the tin foil. It's fanned out because we want the charge to be able to transfer over a wider area. We take that, we're going to end up putting the smaller jar inside the big jar, and we're going to repeat the process on the big jar. We have our fanned out wire that we're going to place on the outside of our jar. And there you have it. That's your Leyden jar capacitor. A capacitor is really just something used to hold an electrical charge. In this instance, our capacitor is a static electricity capacitor. So, as we've shown before, one way manually to create static electricity is you take the piece of PVC pipe with the fur and rub it to create that static charge. And while you rub it against the wire, you're actually sending that static electric charge to the wire. Eventually, enough charge will build up so that the inner tinfoil will be holding a charge with that insulator in between of the glass, and the charge can be sent down into the other one by touching the wires together, and you'll see the spark. An easier way to do this is you take a Van de Graaff generator to charge it. So, lights please. So now, we're going to take the wire, we're going to hold it close to our Van de Graaff generator. Although you're seeing no lightning being sent across, it's still being charged with static electricity. On the inner tinfoil, the static electricity is being held as a charge. After leaving it there for a while, it'll be holding enough charge so when we take our two wires and place them together, you will see a spark. And there you have it, Leyden jar capacitor.
So, a neutron walks into a bar. He orders a Coke. He asks the bartender how much it costs. The bartender replies, "For you, no charge."
So wet. You got don't hit me in the face. Alright, we'll take it. Nice job. You just say my name's
You got it. We're recording right now.
Don't videotape already?
I'm Reid.
One way to show electrical charge, run two balloons.
This is Joe.
Ah.
That two balloons have the same charge. Alright, that failed. Should we add audio to this?
Reid in action.
Don't videotape.
I'm Reid. Here I am.
Don't
I know
videotape.
what I told
Don't videotape if you don't want to get hurt. The Van de Graaff generator does the same thing, but on a larger scale. Start over. Just a small piece of tape. Let's take a time out there.
Lose power?
Time out. You take the Van de Graaff generator, and you can't see. So you can't plug in the Van de Graaff generator. Can you turn on the lights, please? Oh, look at that. Look at the height on that one. That one's coming down real late. Boom! That was awesome.
Oh man.
That's a potato cannon.